now, as mentioned last time, we're done with this chapter. And, you know, this was that weird assorted chapter, assorted topics in Trig or something like that. I didn't love that. It was a weird group of material. Now, that means you gotta have a test. Now, as it happens, we have this is a week where we don't meet on Friday. I want to do at least 2 days of review. So the test won't be earlier than a week from today. And it might be on the Friday of that week. Okay? Here's the deal. I want to make sure that the next test, I want to make sure that the test we take about this goes better the first time around than they have been going. Here's the deal. I think we kind of got ourselves into a bad spot the last 2 tests where a lot of people kind of got crappy grades the first time. And then some people got really crappy grades the first time. And then they get their points back, but there's lots of problems. And let's say you got a 20 the first time around. Okay, well first off, if you worked hard and you got a 20, that's just what happened. I mean, we're going to work with that. But on the other hand, I think sometimes people just sort of came unprepared, took their 20. Okay, well then they go and they get half their points back, or maybe even 3/4. Let's say they ended up with a 60. Well, that's still not a very good grade. And you ended up having to prepare for the test twice. I ended up grading test twice. It's just better off for all parties involved if we get more of it done and working the first time around. Does that make sense? I'm still going to do the thing where you get a second chance to take the test and you get points back and all that kind of stuff. But I'd rather it be how we pick up some points, not the lifeboat that keeps you from drowning at sea. Does that make sense? So, we're going to spend at least 2 days reviewing this stuff. Partly, of course, also because this chapter got so stretched out. I mean, it goes all the way back to the beginning of this grading period. We've had spring break along the way, we've had Easter, believe it or not, we had a snow day along the way. You guys had a field trip, about half the class was gone one time for a field trip. I think also, was it PSATs were along the way or something? This section has just been bombarded, it's been so long with this section. So we're going to take at least 2 days reviewing. Okay? Now, so let's talk about this chapter. Oh, by the way, you might say, wait a minute, you didn't quite finish section 6.5. That's true, I have a plan. Okay? How we're going to finish 6.5 will be part of how we review. Okay? But we're not going to be doing like something wildly crazy. You'll see. Alright, so let's talk about the first half of this chapter. This chapter had kind of 2 main topics. It had this stuff about triangles at the beginning. Not necessarily right triangles. Remember the fancy vocabulary word oblique? Oblique triangles. Oblique triangles are the triangles that they don't have a right angle. And it turned out all this trig stuff that we've been learning kind of works with some adjustments. This business of the law of sines and the business of law of cosines. Then the second half of the chapter was like vectors and complex numbers. We'll save that for next time. So today I want to review this business about law of sines and law of cosines. Now, I'm going to draw your attention to the fact that at the end of the chapter, we got both a chapter review and a chapter test or something. I don't remember, the practice test or something like that. What is the terminology they use back here? There is starting on page 458, there's review exercises, and then starting on page 461, there's a practice test. You guys know the drill. You know where I'm going to really get the problems, right? They're going to come from those things. They're not going to have the same numbers. But you know that's where they come from. So it is useful to us to look at that stuff toward the end of this chapter here and see what makes us concerned and so on, or what the pattern is, if you will. And so if we turn on to page 458, what I want you to notice on that business at the beginning there, it says using the law of sines. In exercises 1 through 10, use the law of sines to solve the triangle. If 2 solutions exist, find both. Without yet actually remembering what law of sines is and what solve a triangle is and so on, that probably sounds like the homework we did in 6.1. Okay? I want to draw your attention then on page 461, when you turn the page, to the chapter test. In exercises 1 through 6, use the information to solve the triangle. If the 2 solutions exist, find both solutions. Hey, that sounds like the same instructions. Except did you notice one thing was missing? Did you notice that on chapter test, it doesn't tell you whether this is a law of sines problem or not? Remember, there were law of sines problems and there were law of cosine problems. Notice that on the chapter test, they're not telling you which one to use. Whereas on the review they did, that's mentioned in the teacher's edition as being kind of a think what will work for your students. Okay? Because here's the deal. I'm not sure it's a hugely great idea for me to just throw problems at you without telling you what kind of problem this is. That won't happen on our test. Okay? On our test, it will say use the law of sines to, or use the law of cosines to, okay? Because I don't really want you guys doing that. Hey, were you guys supposed to be working on a review sheet, or was that the other section that was supposed to be making a review sheet? It wasn't you guys? I must have been the other group. Okay. Just double checking. So, because I was going to use your review sheets to review this. Okay. So right off the bat, one thing to know about that part of the test. Whereas on the practice test in here, it doesn't tell you whether it's a law of sines or a law of cosines problem. I will. Okay? Because it's perfectly fair, it's a legitimate thing that the teacher's edition talks about, is to decide for yourself whether you think it's a good idea or a bad idea, to let them know. And I think it's a good idea. Alright, so our problems will be more like what you see on page 458, where they are like the review exercises, where it will say, use the law of sines to solve the triangle. Hey, what did it mean to solve the triangle? I mean, that's something we did for like 4 days in this class. What do we mean by solve the triangle? That's exactly right, Lisa. We find all the sides and all the angles. So we've got some kind of triangle here. And you have an angle A, an angle B, and an angle C. And remember, that was the pattern we used, where they were big A, big B, and big C. And then the lengths of the sides were the ones opposite each of those angles. And we used little letters to denote them. And solving the triangle means come up with all the angles and all the sides, given 3 pieces of information. Like 2 of the angles, or 2 of the sides, and whatever. 2 angles and a side, or 2 sides and an angle, or whatever. And one of the ways to do it was law of sines, and another way to do it was law of cosines. And how you knew which one of them to use was that whole story of those abbreviations that you learned in geometry, like side, 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 angle, side. I don't remember what all the, which ones. Some of them aren't real. Some of them you can't do. Again, that's not what we're going to do with this. Figuring out whether you use law of sines or law of cosines is not the direction I want to go. So instead it'll say, hey, use the law of sines. Just like it does on those problems right there. Now, notice the sneaky part of those instructions. If 2 solutions exist, find both. Remember, some of these problems, when they gave you the information like this angle and this side, there was more than one triangle that met those. Wait. Let's do one of these first. Let's do number 1. Alright, in problem number 1, they give us that angle A is 32 degrees, and they give us that angle B is 50 degrees, and side A is 16. So this is 50, and this is 16, whatever the units are. Now we know that this is a law of sines problem, so we're going to be using the law of sines. Okay, right off the bat, I can see one piece of information that we can solve. If we're supposed to get all the angles and all the sides, I see one thing we can do right off the bat. It's just arithmetic. What's that? We can find angle C really easy, right? Because A plus B plus C better add up to 180. So 180 degrees minus 50 degrees minus 32 degrees is whatever that side C is. And I'll skip the step of actually doing it. It works out to 98. So this angle here is 98 degrees. So far, so good. Again, we're being told it is a law of sines problem. Therefore, we need to use our law of sines. Hey, wait a minute. How are you going to know the law of sines? Are you going to memorize it? Maybe. Are you going to put a sticky note in your book on the page of the law of sines? That would be great. You're going to make yourself a cheat sheet? That sounds fine. We use the word cheat sheet like in a judgmental way, but actually it's a perfectly fine thing when you have open book, open note test. Make yourself a sheet that's got things like law of sines, law of cosines, and so on it. Sounds fine with me. So, alright. Well, as it happens, law of sines is not that big of a deal. One of the ways to write it would be little a over sine of big A is equal to little b over the sine of big B, which is equal to little c over sine of big C. That's one way to write it. Now, I learned something since when we did this material. One of the things I learned was that this business of this equation was freaking people out because they didn't know what to do with all these equal signs. What these mean is any combination of this works. So like if you have the A's and the B's, use this part of the equation. If what you have in the problem are the A's and the C's, use this part of the equation. If what you've got are the B's and the C's, use this part of the equation. They could have written this out as 3 separate equations. They just combined it all together with that something equals something equals something. But you can pick out whichever 2 parts of that you want, because they are all equal to each other. I think that's called the transitive property, if I'm not mistaken. So, like in this particular problem, we have a, little a, this side, and we want, let's just say, little b. So the part that I have here in black would be the right thing to figure out if we wanted to find little b. Because we have little a is 16, we have big A, it's the sine of 32 degrees, equals, little b is what we're trying to find, divided by the sine of big B, which is 50 degrees. We could clearly just move that sine of 50 over here. Sine of 50 degrees divided by the sine of 32 degrees times 16 equals little b. And for what it's worth, again, I'm not going to actually count it out on my calculator. That works out to 23.13. So now we have this one right here. B equals 23.13. Because at that point, it's all just calculator work. And again, we can do the same thing to get this little c. I would use the equation that we have here in red. A over the sine of big A equals little c over the sine of big C. You have the big C, you have the little a, you got the sine of A, and just go forward from there. And you'll get a number. And we have solved this triangle. Now, well, that doesn't seem all that hard. I mean, it's kind of a neat little equation. It's not that big of a deal. You wouldn't even be all that hard to memorize that thing because it's got a little pattern to it. Hey, why was that section so hard? Oh, crap. That section was hard because of what happens on page 406. See, here's the problem with what happens on page 406. This law of sines works great when you have certain pieces of information. In this case, we had this angle, and this side. In other words, this was an angle side problem. We were told it was a law of sines problem, and you can see it's an angle side problem. We were given the angle side. Great. But here's the deal. Some problems are not going to be happy like that. In some problems, you're given, let me label those 3 parts again here, A, B, C, little a, little b, little c. What if I had given you this angle is 20 degrees, this side is 10 units long, and this side is 5 units long? What kind of problem would that be? Well, I'm giving you 2 sides at an angle. Side, angle. But here's the deal. The side angle problems have a problem. Law of sines will actually not, well, if you have side angle, you could have no triangles that match it, 1 solution in a triangle that works, or 2. It's the so-called ambiguous case. Let's think of a way to remember that. Which ones, your problems will work for the law of sines unless they're a pain in the side angle. Maybe you want to switch that around. Okay? Is that a mnemonic device that will help you, Christina? Yes. If the problem is a side-side angle problem, it's going to be a pain in the ass. Okay? You have to go use that table on page 406. Alright, the table on page 406 is a whole weird territory. We spent like a day on that table. Here's the deal about that table. Remember, if it is a side-side angle problem, it's a pain in the side-side angle, and we have to test it first. First, you have to, excuse me here, you have to figure out that value of h. Notice that the problem here, where did it give you that h? It's in that blue box with yellow highlighting, first line. Consider a triangle in which you are given a, b, and a. H equals b over sine a. So there's this h equals b over sine a. So you have to compute that right off the bat. If it's a side-side angle problem, you have to do that right away. Then, you work your way through this table. Good thing it's an open book, open note test. Do not try to memorize that table. That will just make you unhappy. I don't like it when Christina is unhappy. Don't make yourself unhappy. Memorize the table. Make yourself happy with sticky notes, paper clips, a cheat sheet, whatever works for you. I wouldn't even make a cheat sheet. I'd make a note or something on it, right? All right. First thing you got to check is that top line. Is the angle A acute or is the angle A obtuse? Well, in this problem I gave you, A is 20 degrees. I hope we all agree. That means A is acute. Remember, acute means smaller than 90 degrees. So, in this particular problem, we already know of the 6 columns there, we're in one of the first 4. The last 2, which are the obtuse angles, we don't have to worry about. Okay. Next, let's compute that h. Okay, well in order to get that h, I need b times the sine of a. Well, b I gave us there was, apparently I was supposed to give you b. Hold on, I made it c over here, but let's make it b. Alright. B is equal to 10 times the sine of 20 degrees. What is the sine of 20 degrees? So 0.342 times 10, it'll be 3.42. Okay. That's my h. Alright, so look at those necessary conditions. First column, A is less than h. Let's ask ourselves that. A is less than h. Here, what I learned was you put a question mark on top of there when you aren't sure. Your book doesn't seem to do that, but whatever. So 5 is less than 3.42? No, that one's not right. Look at the next one. A equals h. 5 equals 3.42? No. All right. Third column. Third column doesn't involve the h. A is greater than b. A is greater than b. 5 is greater than 10. No, that one's not right. Next one. Fourth column. H is less than A is less than B. 3.42 is our H, is less than 5, is less than 10. Yes, that's the one we have. Great. Now, which one did that correspond to? That one corresponded to the possibility that, that we have 2 triangles. Crap. It's the 2 one. Alright, what would have happened if it had been 0? If it had been 0 triangles, what that means is that if we actually tried to make a triangle that has this angle, A, and we know the length of the side B, little b, and well, we know the length of this side A, little a, but we don't know which way it's pointing, so it could be in any of these directions. The problem is none of them ever touch that other side. None of them are long enough that they ever make a triangle. Okay, and your answer would be no triangles. If it had been one triangle works, hallelujah. One triangle works, you just apply your law of sines and it's fine. A over A, sine A, B over sine B, all that kind of crap. What if it had been two? I'm not happy with the problems that are where it's two triangles. Not because they're like all that hard, but that they're twice as much work. Okay? You have to do the whole part of the story where you have to remember that like there's two different angles that have the same, like when you have the sine of A, but there's two different angles that have the same value. If you have the sine of A equals 0.8. The problem is there's two angles that have a sine of A that is 0.8, and that's easy to screw up, and even if you get it right, there's twice as much work because you're doing it for two different sets of angles. So here's the deal. Even though in your review session at the back of the book and in your review problems it says, if there are two triangles, find them both, that's not what's going to happen. On the test, what will happen is, any place where I say solve the triangle, it's one triangle. Okay? There will be problems, on the other hand, on the test, that are how many triangles are there that are the solution to this, where you're using this table. And the answer will be either 0, 1, or 2. But you won't, on those problems, actually be solving the triangle itself. I want to know if you can go through that table and figure out how many there are. Does that make sense? The business of there being two triangles, all that does is give you twice as many places to screw up. Okay? That doesn't make me think that you're twice as smart or something like that. Does that make sense? You're not proving anything that you know by doing that. So I think in the interest of a better test, that we will do that. Okay. So working our way through that table, that'll be a thing we got to do. Now, conspicuously, what doesn't happen in 6.1 is a proof of this law of sines. And that's good. I Googled it, and if I remember right, it's a mess. Maybe it's law of cosines that's the real big mess, but whatever. One of them's a big mess. Thank God we don't have to prove it. There weren't any problems that involve proving it. But in the course of proving it, you come across another rule. The rule is given on page 408, called the area of an oblique triangle. Yeah, I'll even write that on the board. Are you guys on Monday participating in that cell thing that's coming? Yeah. Don't tell them that I swear so much in class. Okay. Thank you. That area of the triangle can be written three different ways. 1/2 times BC sine A, or 1/2, I'm going to do the same order they do, BC sine C, I'm sorry, AB sine C, or 1/2 AC sine B. Okay. This is not what you learned in like 3rd grade when you learned about the area of triangles. What did you learn in 3rd grade with like how to do a triangle's area? Here, we're going to call this the 3rd grade solution. Well, how did you learn the area of a triangle? 1/2 base times what? Height. Yeah. This is different. And it falls out of how they derive the law of sines. And we don't have to prove it or whatever. But look what happens. If I've got two sides and another angle, or two sides and another angle, or two sides and another angle, one of these three will be what I've got. Okay? And it's just another way to find the area. While we are on the subject of the area of a triangle, if you flip ahead, the same sort of thing happens on page 416. There it's called Heron's formula, where the area of a triangle is equal to, and it's a weird thing, square root of S times S minus A times S minus B times S minus C, where S was equal to something. What is it? A plus B plus C divided by 2? Yeah. Whatever. This falls, again, we don't derive law of cosines in this chapter, thank God, but this falls out of that derivation. Look what you need to make Heron's formula work. Just the three sides of the triangle. A, little b, and little c. And with just that information, no angles or anything like that, well, you've got the three little sides, you can compute that s, and then this all falls out. This chapter is infested with ways of computing the area of triangles. I mean, right there on the board, I've got 3 different equations, actually 5 if you think of it that way. We got a whole mess of stuff here. But then, depending on what you got, it's easy to compute the area of a triangle. Allow me to be clear on something here. We are clearly not going to ask this 3rd grade definition right here, okay? Thanks, but no thanks. We're not going down that path anymore. But there will be problems on the test that involve computing the area of a triangle, because we've done that quite a bit in this chapter. And, well, basically you're going to either use Heron's formula or you're going to use this other one, which I think they just called the area of an oblique triangle. And you know how you're going to know which one you use? If you've got all 3 sides, use the bottom one. Otherwise, it's clearly one of the ones with that area of an oblique triangle formula. If you've got an angle and 2 sides, use that one. Okay? That's all really neat, by the way, because this is like how land surveyors and so on really do it. Okay? They have some weird shaped piece of property, and somebody's telling them to find the area of it. What they do is they divide it up into triangles and just measure all these sides. And for each of the sides, then, they have an area, and then they just add it up. And it's pretty slick. This is way easier than other ways you might have thought of as how they could compute the area of a triangle, or an area of a weird shape. Alright, so this law of sines thing, we've got pretty much under control. The truth is that formula for the law of sines is not that hard. That A over sine A, B over sine B, C over sine C. It's actually not that big of a deal. In fact, really the only way you could screw it up, and I speak from experience, because I screwed up a zillion times when I was doing the problems myself, is to screw up about the big A and the little a, and the big B and the little b. Really, the only way things could go wrong when you're writing the thing out, remember, it's little a, the side, over sine of big A, the angle, equals. I have made a mistake several times and written it this way when I was doing the problems. No. I've made mistakes when I've written it out when I was doing it myself, and I did it this way. You know, it's little. No. Okay? So if I were making a review sheet / cheat sheet, I would say, make sure that's clear. Okay? Make sure you make yourself a triangle that's sort of your key, where it's clear. I mean A and B and C, the big letters, are the angles, and little a, little b, and little c are the sides. I might even write that out, just to be clear, because that would be the main way you could go wrong on that law of sines thing. That's in contrast to the law of cosines, which you could go wrong in lots of ways. Let's talk about the law of cosines in section 6.2. You look at page 413 in the blue box with yellow highlighting. There's 6 different formulas that they're calling the law of cosines. No, there aren't really 6 different equations that are the law of cosines. There's one different law of cosines that they're just rearranging to put different things on the left-hand side. Okay, it's just that to save you, this isn't an algebra class. Sitting around doing the algebra to rearrange this to whatever form you want isn't your most productive thing to do. I'm sorry, that's page 413. So, I mean, there's really just one law of cosines. They're just writing it 6 different ways. They're just rearranging. See, that way, one version is, hey, I'm trying to solve for little a. That's the first one. Hey, I'm trying to solve for little b. That's the second one. Hey, I'm trying to solve for little c. That's the third one, and so on the second column. I'm trying to solve for the angle a, or for the angle b, or whatever. Again, I'm not going to give you a problem that says solve this triangle and not tell you it's a law of cosines problem. It will say on the test, using the law of cosines, solve the following triangle. Now, let's see what we do with those kinds of problems here. Let's do hey, I like example 1 on page 413. Look, they give us side, side, side. the three sides of the triangle. 8, 19, and 14 in this case. Let's do that. So here's our triangle here. A, B, C, little a, little b, little c. A was 8, B was 19, and C was 14. Is that right? Alright. Alright, and what's this to solve the triangle? Well, look at that over there. We've got all these different forms in that second column of that blue box with yellow highlighting on that page. We've got all these forms that involve the cosine of A equals and then stuff. Or cosine of B equals and then stuff. Well, that's what we have. Everything on those right-hand sides over there is little letters. Those are the sides. So, for example, how about first row, second column of that law of cosines? We've got the cosine of big A equals b squared plus c squared minus a squared over 2bc. Every single thing there is something we have. Except, of course, for the big A. So we're going to do everything over here on the right-hand side, and we're just going to get some number. I'm not doing that number right this second. Alright, we've got the cosine of A equals some number. How do we get A then? How do you go from cosine of A is some number to getting what the value of A is? Super important. You take the inverse cosine of both sides. So if you have the cosine of A equals some number, take the inverse cosine of this side equals the inverse cosine of that side. Which is always a fair thing to do. As long as you do the same thing to both sides, it's always fair. Why do we do this? Why do we take the inverse cosine of both sides? Because inverse cosine of cosine cancels out. These are inverse functions, so inverse cosine of cosine cancels out and just leaves A equals the inverse cosine of whatever that number was. Hugely important. It will be a major challenge to get points on this test. It will be a major challenge to get points on the getting points back part of the test if you don't know that trick. Anytime you've got a trig function of something, like cosine of A, or tangent of A equals stuff, how do you get that A back? Because it's inside that, it's inside that trig function. The answer is the inverse operator. If it's sine of big A equals, then take the inverse sine of both sides, because inverse sine of sine will cancel out. Inverse cos, that would merit being on your review sheet, okay, or your cheat sheet or whatever. That is an important trick. That is high on the list of goals and objectives of the course overall, in all the different sections that we've had. Okay? Knowing that trick. Alright, so this is using law of cosines. Now we would have a number for A. We could pull the same trick for B, because one of those equations is cosine B equals a bunch of stuff, and then you could get that number. Cosine of B is that number. We would solve that by saying inverse cosine of B is inverse cosine of that number. And now this would cancel out, and we would just have the B. And you could really go crazy, go nuts, and do the same thing for C, although that would not be my choice of a way to solve for that angle C. I mean, if I already knew A and B, what would be the best way to get C? Yeah, 180 minus the A minus the B, so that they add up to 180 degrees, right? That would be a whole lot easier than going that whole inverse cosine path one more time. But maybe you do that. But this law of cosine thing was a lot easier. Okay? It was definitely the less stressful option. Hey, I do want to draw your attention, by the way, to the bottom of page 416, where it has put all those formulas for the area of a triangle in one handy place. Okay. Again, sounds like a sticky note thing, or a paperclip thing, or a put that on your review sheet thing. Hey, that review sheet. I mean it. You have an assignment for next time. Your assignment for next time is make a review sheet about the first two sections. Okay? I want to show you, I wanted you to come wagging a piece of paper that this is what you want to bring with you to the test. I mean, you also get the book and stuff like that. But you know what I'm saying? This would help me if this was in my sweaty, cold hands during the... No, wait, you're not going to have sweaty, cold hands in the test because you're going to be confident. My confident math hands will be holding this sheet, and it will help me know what I'm doing. All right? So your assignment for next time is to bring that review sheet. Yay. Okay, now for the rest of the period today, A, work on that review sheet. B, work on whatever problems you don't have done, and I'm going to work on getting grading done. And I will also work on uploading this video, and I am also supposed to